If you're watching this video, it's because you would like to know how to do a hypothesis test regarding two populations. The chapter that deals with this in your textbook is chapter 11. And specifically, what we'll be looking at is three different types of comparisons. So if you're following along at home and you want to kind of cut through what you need to know, it's going to be 11.1, 11.2, and 11.5. I posted something here just yesterday after my meeting, and I see a couple of you have noticed it, but essentially I can't skip that topic. So, or else you're going to be blindsided on the exam. So I will be giving you a extra lesson in this video. But there's some other information there, and please make sure that you take a look at it. Specifically, there's a final review package, but please read this carefully. Okay, so chapter 11. What do we mean by inferences between two populations? Well, just like for one example, let's say I wanted to compare your midterm grade of my section of business students, right? Stats 270 with my stat 245, in other words, my engineering students. These are two different populations, obviously, right? You are in a business program, they are in an engineering program, you guys never see each other, you never hang out, and so on and so forth. So that would be clearly two different populations. And what I would be curious about is there a significant difference? Okay, so in stats 270, so I'm going to say the average of 270, your average was 64.3%. Now that takes into account a bunch of zeros, so it's actually a little bit higher than that. As we talked about, those people would skew it. So this is including everybody that didn't write it, which is quite a few in this group. And now let's take a look at the stats 245. Right, the median here was 72, which gives us a negative skew. Whereas their average here is 84.2. But their median is not skewed here. Their median, well, it's a little bit lower, but 82. Okay, but that's fine, but can I really say that there's a difference here? Like, did somebody perform worse or better? So I'm also going to need a few other statistics here. I'm going to need the sample size as well as the standard deviations here. Yeah, this is a huge standard deviation here as well, 27.21%. We're going to do this. We're going to say the null hypothesis. I guess here you're kind of setting up your data. What do we know? Step 2, our null hypothesis. Again, the skeptic's guide would say, no, there is no difference. There's no difference between 245 and 270. Why would there be? Right? You're both smart. You're both critical thinkers. You have the same teacher. Right? So the alternative hypothesis in this case would be, you know what? There is a difference here. Let's do a two-tailed test. And I say that, you know what? I could have done a one-tailed, depending on who I want to compare what to what, but let's just say it's not 0. Let's use a critical value. Alpha equals, let's just pick something we don't use a lot. Let's say 0.02. All right, so before we go any further and figure out whether we need a t-score or a z-score, right? That's always the decision. It looks based off of just the data we're given is going to be a t-score. Let's look at the formula sheet, right? We're always going to try and match what we have with something on a formula sheet. So um, when you scroll to chapter 11, right, you'll see all this information here. Let's actually just grab that. So these are the three options that we have for comparing two populations. All right, so what do we, test statistic when these are known? Well, we don't know those, so we're not going to use that. We don't know these, so no. Test statistic when these are the same but unknown. Sure. So again, the assumption we're making here, this one looks okay because again, we have the symbols that we need, but yeah, we don't know them, but the assumption we make is that globally, the standard deviation amongst all students is going to be the same. It's a little bit of an assumption here, but I don't see a reason for this not to be the case. We're not going to be using this one because this is not in this example because it's not a proportion question. Right? Please make this diagram whenever you're doing a hypothesis test. It shows that you know what you're doing. Right? It's a two-tail. What is my t? Alpha over 2. Okay, so let's look at our chart. So I'm doing a two-tail, 98% confidence. There we go. Two-tail alpha 0.02. So I'll take this here. Right, whoops. And then my degrees of freedom. In this case, how do I calculate my degree of freedom? N1 plus N2 minus 2. Got it. So it's right there. So what is that? I have, all right, we need to get my sample size here. Let's go do that. At that midterm point, it was like 33. That's right. And then here, I have 13. A difference in sample size here. So, but my degree of freedom, so N1 plus N2 minus 2. So 33, 13 minus 2. So that's 46 minus 2. So the closest to 44, let's go with 45. All right, so my critical score is going to be 2.412. All right, so so that means a little bit different there in terms of the degrees of freedom, but the idea of just using your chart, right? These are always found with charts, right? Critical scores are always found on charts. It's nothing you calculate. It's always just based on alpha and degree of freedom if you're in a T distribution. All right, so the big kicker, right? What is the test score? So this is going to be the variance here, right? Because it's squared. For those of you that remember that stuff from chapter 3. So let's do that calculation first. So my variance is going to be, so N1 minus 1. Okay, so who's going to be my N1? Let's call N1, that's these guys up here. The 270 is N1. So 32. Their standard deviation, or their variance, I guess, would be 27.21. Let's pretend the scores are out of 100. Okay. Plus N2 minus 1, so 12. Their standard deviation was 8.32. Okay, and then finally n1 plus n2, then divided by the degrees of freedom again here. So I've already made this calculation, so 44. All right, so this is a large number. So 557.34. All right, that's fine. Okay, so now we're ready to get into this business here. So you'll notice that this is always going to be 0 because I'm testing for, I guess if we were trying to find if it's not 0, but this is always going to equal 0. So we can just eliminate that. So it's going to be t equals x 270 minus x 245 divided by the square root of this new standard, or this new variance, 1 over n1 plus n2, 1 over n2. So n1, 33. So let's just calculate that denominator first. Again, you don't have to be a hero, right? You can take easy steps. Okay, so this denominator ends up being and then I guess here's the thrilling conclusion. What is these averages, right? So this average was 270 was 64.3 and then 84.2. Ho, 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 it's close. Negative 2.57. And then because it's a two-tail, I also have this t-score over here, right, of negative 2.412. So the answer is yes, there is a difference because this lands in the rejection zone, right? My value is over here. I mean, not quite right over there, but more like over here. I mean, it's close. But nonetheless, it is in the rejection zone, which means that there is a significant difference. So that's exciting. And I guess that makes sense. I mean, there's a huge difference in the averages, huge difference in the standard deviations, but this clarifies that kind of situation. So there is a significant, so basically in conclusion, you say because the test score is greater than the critical score, there is a significant difference in the average on the tests. That really implies here is that I should raise the average of your midterm grade. If you're in the business class, maybe I should have scaled that up a little higher. And so, yeah, stay tuned. I think that's what I'm going to do. All right. That being said, there are, a couple of other variations on it, right? So again, if these are known, then you would do this one and use Z scores, or you would use Z scores and proportions if it's a proportion question. Whatever. Say something interesting. Once you start understanding the logic behind some of these processes, you'll find that it becomes more entertaining as well. So you have to wait a while.